Hey guys, today we're going to be doing tabular integration. It's kind of like a follow-up on our previous video on integration by parts. If you haven't watched that yet, I'd watch that first and then come back. So what even is it? Tabular integration is basically integration by parts but on autopilot. It makes integration by parts a lot faster, but it's important to remember that it only works in certain cases. So when does it work? It works when one part is getting simpler and the other is repeating. So e to the x cosine x, right? If you take those integrals, it's going to repeat. It's going to repeat. It's never going to go to zero. So basically, you use tabular integration when the integrand is a polynomial times an exponential or a trig. Alright, so we'll go over some examples. Integral x times e to the x dx. First thing I want to do, I'm going to make a little table. And I label this d and, oops, let me make this a bigger table actually, like this. Alright, so I'm going to label this table D, this side of the table D, and this side of the table I. So now this is our first step in integration by parts. So, our second step, we want to put the function that quote-unquote dies after a few derivatives in the D column. So, let's look at this. We have two, x and e to the x to choose from. Well, we have to put the function that dies after a few derivatives. If we take the derivative of e to the x, it's never going to die. It's going to always be e to the x, e to the x, e to the x. It's always going to keep repeating. But if we take x, eventually it's going to go to 0, right? It's going to be x, then the derivative of x is just 1, and the derivative of 1 is just 0. Alright, so we stop at 0. Now, what's left, e to the x, we put that into our integration column. So now we differentiate on the D column until we hit 0, and we integrate on the I column until, right, it hits that same number of times. So we differentiated 3 times, we're going to integrate 3 times. So it'd be e to the x, e to the x, right? We stop when it's at that same row as 0. So now we're going to draw diagonal lines like this, right? Boom, boom. Just this. We're not going to go like this, no. We're going to go left to right, like that. Bing, bing. Alright, so if I had another question, like another thing here, it'd be like that, but we don't, right? That doesn't even make sense. Alright, so now, important. The first line is gonna be a plus, and the second line is gonna be a minus. So you alternate, okay? So then if we had a next one, it would be a plus, and then after that would be a minus, right? So now we multiply along the diagonals. So x times e to the x is just x times e to the x, alright? And then we add them up. So 1 times e to the x is e to the x, but it's a minus, okay? So it'd be minus e to the x. Alright, so that's the answer, plus c, because it's an indefinite. There are no bounds. Indefinite, so there's no bounds. So here's our answer. So basically, it gives you the same example, it gives you the same answer as regular IBP, but it's just a lot faster. Alright, so now, I hope this made sense. We'll go on to our kind of medium question. So again, first step. So I see this is, remember how I said in the beginning, it's going to be a polynomial times an exponential or trig, right? So this is a polynomial times a trig. So label our column D and I, boom. So now, which one is going to die? Well, if I put it, it's kind of morbid, but which one is going to hit 0 if I keep differentiating it? Cosine x won't, right? It's going to keep going, cosine, then sine, right? All of that. So x cubed, and then 3x squared, and then 6x, then 6, and then 0. Alright, so now we're going to take what's left, cosine x, and then we're going to integrate down. Alright, so it'd be then integral of cosine x is sine x, and it goes negative cosine x, then negative sine x, and then cosine x. We stop when it's the same row as the 0 on the left column. Now, we draw our diagonals like this. 1, 2, 3, boom. And remember, we alternate. So the first one is always plus, and then minus, and then plus, and then minus, and then we multiply along the diagonal. So x cubed sine x, and then minus, but this minus would become a positive because we're multiplying two negatives together. So it'd be plus, actually, 3x squared cosine x. Alright, so I just kind of made it a little bit smaller so we could see better. So now we did this. So now 6x times negative sine x, this would be plus, but we're multiplying, so it'd be negative 6x sine x. Negative 6x sine x. and then this is a negative, so negative 6 cosine x. 6 cosine x plus c. All right. So the signs are probably one of the most missed reasons that people get tabular integration wrong. All right. So it's important to pay attention to the signs. All right. So, but look how fast this was. All right. So anyway, like I was saying, the most missed part of tabular integration is the signs. All right. So remember, you always start plus and then plus and then minus. All right. So there's your answer, and then finally we're going on to a hard question. Hard question. So here's our last problem. This is a big boy problem. Integral x to the fourth times e to the negative x dx. All right. So let me make our table. Label our columns D and I. Now, by now we should be pros. Which one of these is gonna die when we keep differentiating it? X to the fourth. So it'd be x to the fourth, and then I'm just gonna keep taking the derivatives. 4x cubed. I'm gonna try to be neat because these are a lot of columns or rows. 12x, 24, and then 0. All right. So now what's left is e to the negative x, e to the negative x, and I'm just gonna integrate down. So it'd be negative e to the negative x, e to the negative x, negative e to the negative x, um, e to the negative x, e to the negative x. All right. So now we make our little diagonals. Boom, 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 boom. Now remember we have to do our alternating sign. So it starts with plus, minus, plus, minus, plus. Alright, so now you're going to have to make this a little bit smaller. Again, I wrote too big. Here we go. Alright, so I made it a little bit smaller. Alright, so now we have this. Alright, so now we're just going to do our simple integration or multiplication on the diagonals, right? So it's a plus, but this is a minus, so it'd be minus x to the fourth e to the negative x, and then minus 4x cubed e to the negative x, minus 12x squared e to the negative x, minus 24x e to the negative x, and then minus 24 e to the negative x. And let me make this a little bit smaller too. Alright, and then plus c. So do you guys see how like long this is? It's so much easier if we do tabular integration, right? Imagine having to do integration by parts this many times over, right? This question took us not that long, a minute max again, right? So this is why tabular integration is important. It saves you, I don't know, maybe like 10 minutes you would have to spend doing integration by parts. And 10 minutes is a long time, especially on the AP exam. And usually on the AP exam, they throw one or two tabular ones that you can do using tabular integration. So watch out for those. But that brings us to the end of this. I hope you guys learned how to do tabular integration. This is pretty much one of the hard. It's not that hard, right? The only thing that would change is how long you'd have to, go down. But other than that, you guys should be good. So thank you guys so much for watching. If you have any questions or comments or any videos you would like me to make next, please put them down in the comments below. Like, subscribe, all of that. Thank you guys so much for watching. Happy holidays. It's that time of year again. But yeah, thank you guys so much for watching, and I'll see you in the next video.